Hi, let's look at part 2 for the trigonometric identity. This is the appendix we always refer when we want to solve integration. The first one is something relevant to addition and subtract identity, where you can see there's an addition and subtract part. Double angle identity, where you can see inside is a double angle compared to the original angle. The third one will be product identity, where the summation can be converted to product. So why we need this? For example, if I want to integrate this function, it's very complicated in this form. By using the identity, I can convert this function into a much simpler form, which is I just need to integrate the sine a plus b. So from here, I can directly get the answer. Sine, I get cos, and integrate sine, I should get negative, and the angle remains. And don't forget your constant plus c. So this is your integration result. So let's say you have a distance r here with an angle. If you want to find the a distance here, so your a should be equal to r sine angle. And if you want to find the b distance here, your b should be equal to r cos angle. And sine angle, basically from this relationship, you will just take the distance a divided by r, where r sine angle divided r, you get sine angle. And on the other hand, cos angle is equal to your distance b divided by r. So if you take the sine angle divided by cos, you should know that you get the tangent angle. And if we take the reciprocal for these three functions, you should be able to get the cosecant, secant, and cotangent. So please remember this. So please be careful that this function is not equal to the inversion function for sine, and 1 over cos is not equal to inversion function for cos as well, similar to tangent. Right, make sure you won't make this mistake. Next, let's look at this figure where you should know a squared plus b squared to be equal to r squared. So where your a is r sine angle, b is r cos angle. So if you substitute these two information inside this formula, you should be able to get this answer. And this is one useful identity that we always use. If we divide this by cos square angle, sine divided by cos, you should get tangent. Cos divided by cos, you get 1. 1 over cos, you get secant. This is another useful identity that we always use. Lastly, if you divide it with sine square angle, sine divided by sine, you should get 1. Cos over sine is a 1 over tangent, which is cotangent. 1 over sine, you get cosecant. So this is the third identity. So these three identities you should always remember. Let's look at this triangle. First of all, the distance here is 1. The angle here is beta. So if we take 1 cos beta, we get the distance here in blue color. And if we take the 1 sine beta, we get the distance here in green color. Let's look at the triangle in blue here. We have a distance cos beta and angle alpha. So to find the distance here, it should be cos alpha cos beta. And to find the distance here, it should be sine alpha cos beta. Let's continue with the green triangle. So first of all, we have to find the angle here. So to find this angle, we know that the total angle here is 180 degrees. And the angle here should be 100 minus 90 degrees minus alpha angle. So we should get this angle 90 minus alpha. So in total, 90 minus alpha plus 90, you should get 180. So same thing, this total angle is 180. So to make it 180, this angle should be alpha. So alpha plus 90 minus alpha, it should be 180 as well. Next, from this angle, sine beta cos alpha, you should be able to get the distance here. Sine beta sine alpha, you should be able to get the distance here. We continue to the red triangle. The distance is 1 here, and the angle is alpha plus beta, which can be found from this angle, A plus B. And then we continue to find the distance for the both sides using the same approach. Next, we will compare the distance here on the left and also distance on the right. So these two distances add up give you the sine alpha plus beta, which is equation 1a. And then for cos alpha plus beta, which is this term, it should be equal to cos alpha cos beta, this term, minus with sine alpha sine beta here. This gives you 1b. Then by using this relationship, sine negative beta equal to negative sine beta, or the cos negative beta equal to cos beta, substitute inside this 1a and 1b, you should be able to get these two equations, 2a and 2b. So 1a, 1b, 2a, 2b is called the angle sum and difference in identities, which is very useful in the integration. By using these four equations, by following this formula, we're able to get addition 3 product to sum identity formula. And also, we can get the double angle formula by let the A and B here to be the same. Then you can get the sine 2x formula. By let the A and B here to be the same, you can get the cos 2x. This is called the double angle formula.